Hi everybody. Today is Wednesday, October. Oh, November 1st. Today is November 1st. So we will continue with 6.1 and 6.2. And your homework 6 was due Monday, and your homework 7 and quiz 4 is due Friday. Right, everybody? And our exam 3 is next Wednesday. It covers 5.1 to 5.3. And we already finished 5.1 to 5.3. Right, everybody? Okay, so please do the practice exams. If you have questions about in-class notes or homework or the practice exam, please feel free to ask me. Homework 7 is due Friday. Yeah, and the quiz 4 is also Friday. So quiz 4 is about homework 6 and homework 7 stuff.
I thought homework 7 was due like yesterday or something.
Homework 6 was Monday. Yeah, yes. But doesn't hurt to do your homework early. Okay, good. So let's continue. Everybody able to see the screen? Questions?
I actually did homework 7 on Monday.
Oh, okay. So then just do homework 6 as soon as possible. Okay, yes. Okay. Thank you for letting me know. All right. So last time we talked about optimization problems. Everybody able to see the screen? Okay. So the steps were we identify what we are looking for and what is the unknown quantity to be optimized. Usually you look at the last sentence of the word problems. You want to maximize the volume or area, or you want to minimize the cost, or you want to minimize the time. So it said that in the last sentence, okay? And so then you want to draw the picture. What's the picture look like? Is it a rectangular region, or is it like a triangle, or is it a circle, or is it 3D figures like cube, rectangular, solid, cylinder, sphere, all those things, right? Or cone. Okay, so you draw the picture, and then you ask what is changing and what is constant. Okay, the quantity that is changing, you name the variable, because variables varies, it change, right, everybody? So for horizontal distance, we usually use x. For vertical distance, we usually use y. Okay, a for area, v for volume. And then if you have like cylinder, we know radius is r, height is h. Okay, everybody? But if your number does not change, then you use the number. Don't use the constant. Sorry, don't use the variable, I mean. Okay, because it does not change, so you don't need to set a variable for it. Just use a constant. And the reason why is because in the next steps, you want to find the maximum or minimum. That means you want to take the derivative, right? You're only able to take the derivative of a function with one variable. If you have so many variables, can you differentiate a function with multi-variables? No, not in Applied Cal 1 and Applied Cal 2, we'll talk about that. So that's why you only want to see one variable. Don't set too many variables. Okay, everybody? And again, the derivative of a variable, we use those derivative laws, right? But the derivative of a constant is 0, right? So that's why, if you set too many variables, you don't know, you make the derivative harder, right? Okay, and then you list the relations. Sometimes you might have more than one relation, so you want to substitute. Okay, so let's say if your function has two or three variables, you find some relations so that you can eliminate some of the variable. So your goal is to express your unknown quantity as a function of a single variable. So then you can differentiate, find the critical points, and then find a domain, draw the table, increasing, decreasing, then this is a max. If you have decreasing and increasing, this is a mean, exactly. And then at the end, you check your answers. So if you get something negative area, then you know, oh, something's wrong, right, everybody? So, okay. Last time we were working on example 1, right? I want to make an open top rectangular box with a bottom and 4 sides, but no top, out of paper, which is 8 by 10 inches. So today, I actually bring some props. So I start with the paper, I cut the corner, and then at the side. Now this is the boxes I get. How about let's make a guess? Which box do you think has the largest volume? Blue,
Yes.
white, or yellow? How about let's vote? If you think blue has the largest volume, raise your hand. Okay, 2. If you think white has the largest volume, raise your hand. 1, 2, 3, 4, 5. And if you think yellow has the largest volume, raise your hand. What do you think? Layla, what do you think? Which one? The white one? You? What? The white one? Oh, okay, so we have 2 versus 7. Let's calculate and see the answer. Okay? So, are you all able to see the screen? So last time we set up we draw the picture, right? And we figure out the length is 10 minus 2x. And the width is 8 minus 2x, right? And then the height is x. So our volume, length times width times height, put those in. But you get products because we don't want to use product rule, right? It's actually a product of 3 factors. We don't want to use product rule. So we distribute, then we get a degree 3 polynomial. Now let's differentiate. Okay, so what is the derivative? Okay, let me get back my orange color. Okay, Blaine, what's the derivative of 4x cubed? Blaine, what's the derivative of 4x cubed?
The 12x squared.
Yes.
Negative 72x.
Yeah, very good. And now we will try to find the root. Okay. Are there any common factors, Will?
12.
12? Okay. Let's see. 80, but is 80 divisible by 3? Not quite, right? So the common factor is 4. If you factor out of 4, what's left?
3.
Minus 72 divided by 4 is
24.
72 divided by 4. So 1, 4, and then what times 4 is 32? 8, yes. So 18x. Hi, Garrett. Today you gotta teach me how to do this. Yes. See? Why? Okay. It was fashion. Yeah.
No, it's on duplicate. Okay. Thought this might be the issue last time and I was mistaken, but.
Yeah, it's like this. So last time did you touch something here?
Yeah. That's the weird part is, Tom was talking about last night, he was in here, and everything was working fine, that's the part I get confused in. There's only one other class in here between last night and your class. When he's in here, so that's the part. I guess I gotta ask them whether they're running into the same problems and they're just not using it, or what's up. Okay. So let's get everything back on. We go for, let's see this time. I know what I can do, but it's not something you should be doing, so that's why I'm trying to find a solution you can do. Yeah, okay, it's just let's go for it.
So you press the audio.
Yeah, it's counterintuitive, but last time though when I rebooted it, I managed to get the wires storm, which is the confusing part. Okay. Let me ask Tom and see what he thinks about it.
Okay. So we factor out the 4, and then the 80 becomes what? 20, right? And it's a quadratic function, right? So we either factor it or use the quadratic formula. Looks like we cannot factor this, right? It's not getting the right answer. So let's set this equal to 0 and use the quadratic formula. So what's the quadratic formula? Minus b, and b is, so it becomes positive 18, plus or minus square root of b squared, 18 squared, minus 4a, what is a? 3c, what's c? 20, all over 2a, a is 3. Okay, everybody, plot this in your calculator. What do you get? Yes. Oh, you do plus first, and then you do minus separately. Yeah, there's no way that you can do both at the same time. And also, you need a parentheses around the numerator. So, but wait, no, I mean when you type in your calculator. Yes. So, what do you get? Okay. So I got 1.4725. Okay, it's a decimal number. I just want to 4 decimal places, or 4.5275. Okay, everybody? So we get 2 numbers. And then you think about what is the domain. So what is the domain of x? Okay. What is the smallest x could be? So you have a paper, your smallest x is like 0. You don't cut anything, then you only have a flat paper, right? Then the volume is 0. Okay, everybody? The smallest is 0. And how big? What's the biggest possible? Remember, this paper is what? It's 8 by 10 inches, right, everybody? So you cut out the corner. The corner is at most 4 because it's 8 by 10 inches. Your corner is at most 4. So 4 plus 4 is 8. Let me draw a picture. So if you cut out 4, okay, do you see when you cut out 4 and you only get the middle strip left? But that's the maximum you can cut out, right, everybody? So the domain is 0 to 4. Oh, look at the root. Do you see the 4.5 lies outside? Oh.
How did, okay, all right, okay.
So what did you do?
So what happens,
Okay.
well, you can try next time.
Yeah.
Press Windows P,
Windows
switch
P.
it to extend, and then switch it back to duplicate. And that's
What?
Yeah, I do not believe that, but it
Oh my gosh. Okay, say again. Windows.
You press the Windows key, which is these 4 little squares in the bottom left here, and P at the same time, these 2 keys.
Okay,
And
Windows
then,
P.
Yeah, it should bring up a menu like this. Switch it to any one of the other options, and then switch it back to duplicate. And apparently that works.
Okay. Thank you. Magic. Magic. You know, sometimes my computer is something wrong. I just restart it, but it was like this.
Maybe it's I'm not going to theorize. That's not my thing. All right, it's working out.
Okay, thank you so much. Give me a clap. Yay. Okay. Okay, so let's get back here. Okay. All right. Okay. And this here. Okay, sure. So you have a paper, right? And the smallest you cut is 0. You don't cut anything, then you just get a flat paper. So your volume is 0. And what is the largest you can cut? Well, you have 8 by 10 inches. The largest is you cut 4, right? If you cut 4 and then it looks like you just cut out this and this, you only get a strip of paper. This is the maximum you can cut. Because here is 8, right? Your square must be fit in here. So the largest you can cut is 4, the half of 8. Okay, everybody? And we know 4.5 is outside of the domain, so we don't consider that as a critical point, right? Then we can draw the table. So we draw the table. We have 0, okay, 0 and 4. Oh, let me make it longer, okay? Let me make it longer so you can see better. Okay, 0, 4. So 1.47 is in the middle, right? Not exactly the middle, but in between 0 and 4. And then we have the volume. So volume prime and volume. This is what we're looking for. And we know at the critical point, the V prime is 0. Right, everybody? And then this interval, I can actually plug in 0, right? Because 0 is inside here, right? On the left. 0 is on the left. So if you plug in 0, do you see this is 0, this is 0? I get 4 times 20 is positive. So on the left region is positive, and then on the right region, any guess? If you pick a big number, let's see. Let's plug in 4. So 4 times 3 times 4 square is 16 times 3, 48. Right, everybody? So we plug in 4, we get 48 minus 4 times 18 is 72, right? And then plus 20. Do you see we get what? 6, yeah, negative. Therefore, V is increasing, right? If V prime is positive, V is increasing. And then if V prime is negative, V is decreasing. And then that point is what? Max or min? Max. And this match with our goal. We want to maximize the volume. So we get, okay, it asks what size of the square. So we say we get maximum volume when x equals 1.4725. And 1.47 inch is this one. So you two win. Yeah. This is about 1.47 inch. Okay, everybody? Mm-hmm. Yes. Okay, so this is example 1. Okay, sorry, the projector takes a lot of time. So let's continue on example 2. Okay, a manufacturer needs to make a cylindrical can that will hold 1.5 liters of liquid. Determine the dimension of the can that will minimize the amount of material used in its construction. So it kind of makes sense. You have like your soda or a can of paste. You want to have the amount, the volume, it holds the same amount of liquid paste or soda, right? But you also want to minimize the cost to make the can, right? So less surface area possible. Okay, so this is the problem. And it's a cylindrical can, so we draw the picture is a cylinder, a circular cylinder. Alright, circular cylinder. Your variable would be the radius and the height. Right, everybody? We want to know the dimension of the circular cylinder. So we want to know the radius and the height. So that we get the volume. See, 1.5 liter of liquid. That is the volume. And 1 liter is 1,000 centimeter cube. Is that okay, everybody? Yeah, 1 liter is 1,000 centimeter cube. And you want the volume to be 1.5 liter. Oh, excuse me. Thank you. So it's 1,500 centimeter cube. And you know this number is fixed. Okay. You want to relate it to our variable R and H. What is the volume of the cylinder? What's the volume of a cylinder? Yeah, pi r squared h. For all the cylinder, no matter it's a circular cylinder or your base is a square or your base is a triangle or any shape, for cylinder, the volume is always area of base times height. Okay? So area of base times height. But in this case, our base is a circle. That's why area of a circle is pi r squared. And times height is h. Is that okay, everybody? So we have V equals pi r squared times h. And we want to minimize the amount of material. Well, amount of material is the surface area. Okay? So our goal is to minimize the surface area. Is that okay, everybody? Surface area. Okay, do you see we have the top and bottom is 2 circles, right? Area of circles is pi r squared. So we have 2 copy of circle. And the side, when you cut it and you open it, do you see a rectangle? Surface area. Top and bottom, they're circles. So pi r squared. There were two of them. And then the side, when you cut it and open it, do you see it's a rectangle? With the width is height. And the length is the circumference of the circle, right? So therefore, this is height, and then this is the circumference of the circle, 2 pi r. So the area of rectangle is the length times width. So far, so good, everybody? We want to minimize the x. So we want to take the derivative of x. But do you see we have two variables, r and h? We're not able to differentiate a function with two variables. But they have a relation. We can use this relation to eliminate one of the variables. Let me ask you. We can solve for r in terms of h, or we can solve for h in terms of r. Which one is easier? Express r in terms of h, or express h in terms of r? Which one is easier? Huh? So 1500 equals pi r squared h. We want to substitute, we want to get rid of one of the variables. So you either express h in terms of r or express r in terms of h.
Express R in terms of H.
Okay, if you express r in terms of h, what do? You both sides divided by pi h, but then you need to take square roots. So you have square roots. Can you see that, everybody? But if you want to solve for h in terms of r, you just both sides divided by pi r squared. You don't see square roots. Okay, everybody? Do you like square roots? When you take the derivative, exactly, right? So there are two different ways to solve this problem. But the easier way is we express h in terms of r. So h is 1500 over pi r squared. This is from this equation. Is that okay, everybody? So there are more than one relation. This is how we can reduce the number of variables. So we substitute this here, okay, to get rid of h. So plug in. We get 2 pi r squared plus 2 pi r. H is 1500 over pi r squared. Is that okay, everybody? All right. Let me see. Am I recording? Oh, not here. Okay. Are we recording? Okay, good. All right, so continue. We simplify. So before you differentiate, please simplify. Do you see the pi we can cancel, right? And one copy of the r we can cancel. Yeah. So we cancel one copy of the r, and we cancel the pi. We get 2 pi r squared plus, do you see 2 times 1500 is what? 3000. And it's over r. Right, everybody? And before you differentiate, make it into the standard form. The standard form is 1 over r is r to the what power? -1. Yes. When you use the power rule, please make them into the standard form. Okay, everybody? Yeah. So we're ready. We get s is a function of a single variable, so we can differentiate it. So s prime Dylan, what is the derivative of 2 pi r squared? 4 pi r. How about the derivative of 3000 r to the minus 1? Yeah, negative 3000 r to the negative 2. Yes, everybody? Mm-hmm. Okay, do you remember when we find the critical points? If some term you see negative exponent, it means this thing is actually in the denominator, right? So this is in the denominator. And when you see some terms have denominator, what do? We already finished the derivative, so don't need to do the quotient rule again. Quotient rule is when you take the derivative of a quotient, but here we already take the derivative. Our goal is to find the critical points. Do you still remember from chapter 5? Once some term has a denominator, you combine them into a single fraction, right? What's the common denominator? R squared. So the first term, you multiply by r squared and divide it by r squared. So you get r squared. 4 pi r what? Cube minus 3000. Is that okay, everybody? Yeah, combine into a single fraction. You set the numerator equal to 0. That corresponds to the derivative is 0. You set the denominator equal to 0. That corresponds to the derivative does not exist. Remember that, everybody? Okay, so numerator, which is, so we set, okay, numerator equal to 0 corresponds to the derivative is 0. So 4 pi r cubed minus 3000 is 0. How do you solve for r? What do we do? Paige, how do we solve for r? Yes, add 3000 on both sides. And then? Yeah, divided by 4 pi. Then, what do we do? Cube root it. Yes. Or you can say raise to the 1/3. Same thing, cube roots. And raise to 1/3, same thing. Okay, this is the numerator. And then the denominator equal to 0. It corresponds to the derivative does not exist. Denominator r squared is 0. Oh, what is r? 0. Yes. Okay, now let's figure out the domain of r. Okay. What is the smallest r? I would say it's very small, but you cannot get 0 because your volume is 1500. If your r is 0, your volume will be 0. Right, everybody? Your r could be as small as possible, but not equal to 0. It's just your height is going to be so long. Okay, everybody? Yeah. So the smaller is 0, but not including the endpoints. What is the largest r? Infinity, right? Okay, you can have r as large as possible. Your h is just going to be very small. Okay. Good. Do you see 0 is not a critical point because it's not in the domain? Right. So we can draw a picture of the table. So 0 is not included. So we put an open circle to denote the point is missing. Right, everybody? And this number 3000, by the way, can you put this in your calculator? What is this number about? Give me 3 decimal places. Dylan, do you get a number? Oh, yes. 6.2, give me 3 decimal places. Oh, okay, thank you. So 6.2, let's just put a small number there. And we are talking about the S-pline and S. Everybody okay with this table? We only put S-pline and S. But in your next exam, if I ask you to draw the graph, sketch the graph, your table will contain the critical points and your possible expressions. So it includes the first derivative, the second derivative, and the function. Remember the function? How do you draw it? The shape is a circle. You tell it it's before pieces, right? Okay, that is the actual shape of the function. But here we only need to know is increasing or decreasing. So 6.2 is the numerator is 0, so the derivative is 0. Okay, could you pick the number here from 0 to 6? What number do you pick? 1. Okay. 4 pi times 1. 4 pi. 4 pi minus 3000. Positive or negative? Negative. 1 squared. Positive. Together is negative. Okay, how about here? You can pay R to be, how about 1000? I'm sure if you put R as 1000, this is positive, right, everybody? Yeah. So this is positive. And then your function is what? Decreasing. Yeah. And then increase, right? And then what is this point? Minimum. Are we looking for minimum? Yes. So in the exam, please include all the steps, including this table. But you will see the minimum, it always match with your goal. If you get the opposite, something wrong. Maybe your derivative is wrong. Okay, your critical point is wrong, or your domain is wrong. Okay, so we get minimum surface area when R equals 6.203. And because you want to know all the dimensions, you also need to know the h. So h, okay, h is right here. 1500 over pi r squared. So 6.203 squared. So what is this number? See, we need to know all the dimensions. So we need to know R and H. What is 1500 over pi and 6.203 squared? What? 13.175? 12.4 sounds better, yes. So 12 point what? 3 digits. 409. Okay, thank you. All right, and the unit is what? This is centimeter cubed, and this is centimeters. Yes, cm. So that finished the problem. So far, so good, everybody? Yes? So we continue. Okay. All right, example 3. So sometimes make sure you plug in the parentheses. Okay? If you don't put the parentheses, then you have to say divide by pi and then divided by the square. Yeah. Okay, example 3. A window is being built and the bottom is a rectangle and the top is a semicircle. If there are 12 meters of framing materials, what must be the dimension of the window to let in the most light? Okay, everybody? So, what is 12 meters? Sometimes you look at the units and you can tell. Meter is length. Meter square is area. Meter cube is volume. Right, everybody? So here you are given 12 meter. Meter is the length. So it means the perimeter is 12. Okay, everybody? So let's see. Okay, the variable, it already set up the variables R and H. So we know perimeter is 12. And what is perimeter? Okay, do you see this part is half of a circle? What is the circumference of a whole circle? Circumference, the length. 2 pi r. Not the angle. Circumference is the length, the perimeter of a circle, not the angle. Yeah, the angle is 360 degrees or 2 pi, but the circumference is 2 pi r. Right? And this is half of a circle. Pi r, exactly. So we have this is pi r plus, what's this? H. And this, H together. 2H. Yeah, the length. So 2H plus, and the bottom, 2R. And because this is R, this is the diameter, so 2R. Right, everybody? So we get 2R. Okay, so this is a relation between R and H. And our goal is to let in the most light. So that means we want to maximize the what? How do you let in the most light? The area. Yes, area. Okay, so if the geometry figure is 2-dimensional, you just say area. But if the geometry figure is 3-dimensional, then you say surface area. Okay, so here, area. Let's use A. Okay, what is the area? You see we have a rectangle and a half circle. What's the area of the rectangle? Yeah, H times 2R. That's the rectangle. How about the half circle? 1/2, what's area of a circle? Pi r square. Yes, everybody? Okay, good. Now, our goal is maximize the area. So set up the problem. So far, so good, everybody? Do you see the area is a function of 2 variables? Can we differentiate here? No. We need to reduce the number of variables into 1, right? But there is a relation between R and H. Questions? Do we solve for H in terms of R or solve for R in terms of H? Which one is easier? H in terms of R. Because the H, there are 2 terms with R, but there's only 1 term with H. Okay, and the coefficient of H is easier. Right, everybody? So, therefore, we can solve for H. By the way, if you solve for r in terms of h, that also works. It's just the time that which method is easier, you use less time. Okay, so solve for h. And so we solve for this, we get what? 2h is 12 minus pi r minus 2r. Right, everybody? You move all the other terms to the other side. So what is h? Both sides divided by 2, right? And what's 12 divided by 2? 6. And then we have pi over 2r. Oh, and the 2r divided by 2 is just r. Right, everybody? Okay, nice. We can plug in. So we plug in. We get a is h times 2r. Well, our h is 6 minus pi over 2r minus r. And we multiply by 2r plus 1/2 pi r squared. So far, so good, everybody? Oh, when we multiply by 6 times 2r is 12r. And then a negative pi. Do you see the 2 and 2 cancel? So negative pi r squared, right? And minus r times 2r squared plus 1/2 pi r squared. Can we combine the like terms? Do you see the negative pi r squared plus 1/2 pi r squared? What do you get? Yeah, very good. And then minus 2r squared. Right, everybody? Okay, let's also differentiate it. We take the derivative. What's the derivative of 12r? 12. And then next, pi r, no square, right? Yeah. And minus 4r. Right, everybody? This is the derivative. We set this equals to 0. And we solve for r, right? So, these two terms has r. We move to the other side. It becomes what? Pi r plus 4r. So far, so good. And what do? You can factor out the r. You get pi plus 4. Right? And so what is r? Yes. Okay. Let's continue next class. Okay. Yeah, so the projector takes sometimes we didn't go over enough examples today. Okay. So yeah, please do your homework 6 and homework 7. The quiz is on Friday, and the exam is next Wednesday. If you have questions, please come to see me. Okay. Bye.
You see, this we go early tomorrow on Friday.
But make sure you watch the lecture.
Yeah, no, I was gonna leave a little early. Just leave a little early from class, so like 20 minutes early.
Oh, because of.
We're traveling to Kentucky on
Oh.
for wrestling, so.
Oh yes. Good,
Yeah.
Good. Good luck.
Yeah.
Hey, do you know Lucas?
Yeah, no, Lucas.
Yeah, he's also in my other class.
Oh, which one?
Oh, pre-calculus.
Oh, okay.
Yeah. Okay, bye.